Hey guys, this is writing the equation of a sine or cosine function given its graph, problem type 2. So we have done several exercises like this one, but we were only asked to find A and B. Now we can have C or D too. So in here I have the four variables that we want to find. And in here I have the shape of sine and its negative, and also of cosine and its negative. You're gonna know that it is a sine function if it starts at the origin. It depends on where it goes after that. If it goes up, it is the positive sign, and if it goes down, it is the negative sign. And cosine starts somewhere else than the origin. If it starts in the positives, then it is the positive cosine. If it starts in the negatives, it is the negative cosine. So let's proceed with finding the first letter A, that is the amplitude of the wave graph. So actually you can see that it is half the distance from the lower part and the upper part. So in my case, it is just 1. So A equals 1. That was an easy. Then let's find letter B. Letter B is the, how do you call that? Oh my God, how do you call it? The period, sorry. Yes, that is a period. The distance where the wave function starts over again. So you can use whether the two upper parts or the two lower parts to calculate that. I suggest you do that. So as you can see in here, it goes from minus 2/3 of pi to pi. So maybe you will have to do an operation like this one. The distance between those is a subtraction, 2 pi minus 2/3 of pi. Be careful with those two minus. That equals, in terms of thirds, it is 6 pi plus 8. I'm sorry, plus 2 pi, that is 8 pi over 3. Okay, that is just the distance. But to calculate the value of b, you have to divide 2 pi by that distance. So 2 pi divided by 8/3 of pi, I'm making the numerator a fraction by divided by 1. And after a sandwich, we will see that that equals 6 pi over 8 pi. Pi over pi equals 1. So we just have 3/4. That is the value of pi. That is the value of b. All right. Now C. C is the number that creates a horizontal shift, a horizontal phase shift. That's what we call it, right? So notice that in our function, in my function, I only have a vertical shift because I can move the wave function down, and I didn't do any horizontal movements. So that means that C equals, well, C equals 0 because there is no horizontal movement. And also we can see that the shape of the function, if we translate it into the origin, it is a negative sign. So we're going to use that too. C equals 0. And the last part is D. Actually, that is the vertical movement, the vertical shift. And as you can see, there is a movement of 3 units. So D equals 3. And that's it. So using this shape that we noticed, it will be a negative sign, and we are going to use the numbers that we got, that is -1 because a equals 1, sine of 3/4 x plus 0, that is C, plus 3, that is D. And that's it. I'm gonna input that a little bit simplified because I don't want to write that 1 times minus sine of 3/4 of x plus 3. That 0 is doing anything, so I'm not writing it either. It is correct. Thanks.